everyone, welcome to the first lesson on our triangle unit. Hopefully this will be a good review for you and just to refresh your memory on the different types of triangles. So hopefully you have your note sheet in front of you, and we're going to go through the two different ways that you can classify triangles. So the first way is to classify by the types of angles that are in the triangle. So there are three different ways, and we'll go through them in a minute, but just so you can see on that paper, you'll see the first one is the equilateral, the second one is the isosceles, and the third one is the scalene. Okay, so we're going to go through and we're going to fill in those blanks in your note sheets as we go along. So the first one we're going to take a look at is the equilateral triangle. An equilateral triangle means that all of the angles are equal. So for example, you would put swoops in every single angle, stating that they're all the same. If it's equilateral, it's also going to have the same sides. So if they have the same angle, they have the same sides. So if we look at the triangle on your paper that says ABC, if you're going to name this triangle, remember you're naming it by its government name. So you would name this triangle by saying this is triangle ABC. You could also name it triangle BAC. You could start with the C and name it CAB. It doesn't matter. Any three letters, that's how you would name the triangle. Okay, now about its angles, you see that we have three angles in here. And you'll learn this in a second, but each of these angles have to be equal. Inside of a triangle, each triangle has to add up to be 180 degrees. I'm going to show you that. I will prove it to you later. But since each of them have 180 degrees and they have to be split equally, if you divide this by 3, you will get 60 degrees. So each angle inside an equilateral triangle are always going to be 60 degrees. So that's the fun part about equilateral triangles. Alright, let's take a look at the next one. The next one is an isosceles triangle. And if you forgot what isosceles means that you have two sides that are congruent. So in our picture, we're going to say that AC is congruent to AB. And remember that when you mark it with little slashes. So we're going to mark those two having the congruent sides. Not only do they have two sides that are equal, but then two angles are also equal. So these are called right here the legs of your triangle, the ones that are equal to each other. The bottom, that is not one of the congruent sides, is called the base, which makes these two angles right here the base angles. And the base angles are the ones that are equal to each other. The one angle that's not equal is the one at the top here, and this one is called the vertex. So the vertex is the one that is at the top, not congruent. The bottom two base angles are congruent. Okay, the next one is the scalene triangle. The scalene triangle is a triangle that has really nothing special about it because no sides are equal. So scalene means no congruent sides. If we were to name this triangle, again, you could name it in several ways. Remember, you could say triangle ABC, you could say CBA, you could say whatever you wanted. Those three letters in any order would name that triangle. Now, because no sides are congruent, if no sides are congruent, no angles are congruent either. So there's nothing special about a scalene triangle. Alright, next on the list is how can we classify according to the sides. So now we're going to look at the equal angular triangle. So there's 4 different ways you can classify by looking just at their sides. So equal angular is basically the same thing as equilateral. All this means, again, is that their angles are all equal and the sides are all equal. It has to be true for one of the other ones to be true. If it's equal angular, it has to be equilateral. So what this is saying is, again, all of these angles on the inside are going to be 60, and whatever I put out here, if this is an 8, they all have to be 8. That's what equilateral and equal angular mean. Alright, the next one is an acute triangle. An acute triangle, if you remember what the term acute means that it is less than 90 degrees. So if it's an acute triangle, all angles are acute within the triangle. So that means every single angle has to be less than 90 for it to be considered an acute triangle. And so again, we will learn about this later, but let's say that we had this one is 50 and this one is 60. That leaves us with a total of 130 degrees, and there has to be 180, so the last one would be 50. Okay, so this would be an acute triangle because all of them are less than 180. Now, one of the questions on your worksheet is to name the angle opposite of AB. So if we label these as ACB, here is the side AB, so the angle opposite is going to be the angle right here, angle C. So angle C is across from or opposite of the side B. Alright, next on the list is obtuse. Okay, an obtuse triangle, if you remember what obtuse means, it means that it is greater than 180. But here's the thing, is you can only have one angle that is greater than 180. If you have, so let's say you had this angle right here, and we made ourselves a triangle, an obtuse triangle. Let's say that we tried to make another one, like this right here. We tried to make this guy obtuse. So now you have like a 100-degree angle, 100-degree angle. The only way you can close this off is to make a quadrilateral. So it is impossible for a triangle to have more than one obtuse angle. Okay, so we're going to go back to this guy. Let's erase this. And let's go back to the example at hand. So we have an obtuse triangle that looks like this on your notes. Something like that anyway. You have ABC. Right? They asked you to name the side opposite of angle A. So here's your angle, angle A. So the side opposite is going to be over here as CB. So CB is the side that's opposite of angle A. And again, here's your obtuse angle. Angle C is your obtuse one. Remember, there can only be one obtuse angle. Alright, next, last but not least, the right triangle. Okay, the right triangle, again, means that you have one angle that is 90 degrees. Again, it can only be one, because if you think about it, here's your right angle. If I tried to make another right angle, the only way I could close this shape off is to make it a square or a rectangle. So you can only have one 90-degree angle. So let's label the parts first. There's a lot of parts in a right triangle, which we already know. So remember, the longest side over here is called your hypotenuse, and the other two are called your legs. And remember that the hypotenuse is always opposite of your right angle. Okay, the other two sides, like I said, then are called the legs. So those are the parts you need to know for your right triangle. Again, right triangle only has one 90-degree angle. Okay, I'm going to give you a minute. I'm going to draw the practice examples at the bottom here, and I'll give you a little entertainment while you are trying to classify. Remember, you are going to try to classify according to if it's sides and by its angles. All right, let's see if you had enough time to figure these out. So each of them have to be classified two ways. So the first one, if we look at it, let's look at its sides first. So we know here these marks mean that they are equilateral. Okay, and if it's equilateral, it has to be equiangular. They have to go together. Equiangular. Okay, so equilateral, equiangular are going to go together. Even though they didn't mark these, you can mark them in. It's okay to assume it. Okay, let's go to number 2. So right away, let's go by the sides. You have 2 slash marks. So if there's 2 slash marks, this means that it's going to be isosceles. Then if you look at the angle, you have a right angle. So this is going to be a right isosceles triangle. Again, every triangle can be classified two ways. All right, last but not least, we have this. If we look at the sides, there are no markings whatsoever on here. So if there's no markings, nothing's equal. It's going to be scalene. Now if we look at the angle, okay, we can clearly see this would be acute, this is acute, this is obtuse. So since there's one obtuse angle, this is going to be an obtuse triangle.